In this lesson, we're going to be talking about special angles. So as the terminal arm rotates around the whole rotation, there are certain angles that we consider special angles or that we call special angles. So obviously some main ones include 0, 90, 180, 270, 360. Those are pretty obvious. But there are more angles that we're going to be talking about today that we can find that we're calling special angles. So angles like 30, 45, 60. These angles would continue into all four of the quadrants. So 120, 135, 150. And then obviously continuing on. In order to find these special angles, we do have two special triangles. These will have to be memorized. They're going to be used to create your unit circle, which is something we're going to be talking about in the next slide. But if you know these two special triangles, you can come up with every single value in the unit circle. So the unit circle isn't necessarily something that I need you to memorize. These two triangles, absolutely. So for now, draw them, keep them in a special spot, keep referring to them, but you will need to know them off by heart. So our first special triangle is the 1, 1, root 2 triangle. This is an important triangle. If you even just remember the 1, 1, you could calculate the root 2 by using Pythagorean theorem. Since we have two sides the exact same, that means that two angles need to be the exact same. Since this is a 90-degree triangle, obviously the missing angles both need to be 45. Now, our second triangle, I don't know why I just did that. Our second triangle is the 1, 2, root 3 triangle. A lot of people want to put the root 3 on the hypotenuse, but root 3 is actually smaller than 2, so that's a good way to remember that. This triangle has an angle of 30 and an angle of 60. So depending on how you want to memorize it, I remembered that the 30-degree angle is always closest to the root 3. Like I said, it's totally up to you what you want to do to remember that. Now, you're probably wondering, okay, why am I getting these special triangles? How can I use them? What is going on? You will see questions where I or your teacher says, provide an exact value. So these triangles give us an exact value. Notice the root 3 and the root 2, those aren't decimals, and so if you tried to plug that into your calculator, you would get a decimal answer, and that's not what we want. So when you're using these triangles, you could calculate any kind of primary trig ratio. So for example, sine of 45. So we know that sine is opposite over hypotenuse. Now these are both 45s. It doesn't matter which angle you use. You'll get the same for both. I'm just going to use this one. So here I have my opposite of 1 and my hypotenuse of root 2. I could do the exact same. I could do cos of 45, and I would get my adjacent over my hypotenuse, so 1 over root 2. I could do tan of 45, my opposite over my adjacent, so 1 over 1, so 1. Using the bottom triangle, I could do sine of 30. And I would get, here's my 30, my opposite is 1, my hypotenuse is 2. I could do sine of 60. I don't know why I didn't write a 30 in there. Sorry about that. My opposite of 60 is root 3, and my hypotenuse is 2. Now, the same way I could do cos of 30 and 60 and tan of 30 and 60. So here you will see I did cos of 30 and 60 and tan of 30 and 60 for you to get those answers and double check them yourselves. Alright, so the last thing we're going to be talking about in this lesson is the unit circle. So the unit circle is a special circle. It has a radius equal to 1. And we've already been talking kind of about this whole terminal arm, point P, and labeling that. Now we're just adding a circle to the mix. So what I'm going to show you here is that we know that if we make this triangle using this point P and our terminal arm, we have our theta here, and we know that this distance is x and this distance is y. Now, when I'm taking a look at what types of formulas I can create from this, sorry, I'm going to add an r in here for my radius, which we know is 1. I can say sine of theta is equal to, we know sine is equal to opposite over hypotenuse, so sine of theta is equal to y over r. Now, since this is a unit circle, we know the radius is 1. We can say sine of theta is equal to y. I can do the exact same thing. I can say cos of theta is equal to a over h, or adjacent over hypotenuse. Cos of theta is equal to, my adjacent is x over my hypotenuse is r. Since my radius is 1, I can say cos of theta is equal to x. So basically, instead of this x, y coordinate that I'm getting right here, I can rewrite that as x, which we say is cos of theta, and y, which we say is sine of theta. So how is all of this helping me? So here I have a blank unit circle. You can see the lines or the terminal arms that are drawn in here. So we've got, the 0, the 90, the 180, the 270, the 360. I've got my 30, my 45, my 60. I've got my 120, my 135, my 150. So all of those special angles that I've talked to you about have been drawn in here for you. So what I'm going to get you to do is I'm going to get you to fill in the unit circle. And then on the next slide, I will put the filled in version for you. So you're going to have to pause it, double check your work, but it will all be there for you. So when we're filling this in, I'm going to do a couple with you. We're going to be using our special triangles. This is why I said you don't need to go and memorize the unit circle. Some teachers will tell you that you should be memorizing it, but really I think having an understanding of where it comes from is going to be better for you. There's no point in memorizing this whole thing when you can figure it out. So when we're calculating our answers, we just figured out that this first coordinate, or our x-coordinate, is going to be cos of that angle, cos of theta. The y part is going to be sine of theta. So I'm going to go ahead and I'm going to figure out 0, okay? So I know that this right here is going to be cos of 0. Now I can do that on my calculator. I can do 0, 90, 180, and 270 right on my calculator. I get whole numbers. So that's okay. So cos of 0 is 1. And sine of 0, which is how I figure out my y-coordinate, is 0. I'm going to go ahead and move to the 30-degree mark, okay? Depending on if you want to fill this in, you can do that. If you just want to write a 30 degrees here beside it so you remember, that's okay with me too. Now, on a separate sheet of paper, probably, I would draw my special triangles. So I've got my 1, 1, root 2, 45, 45. I've got my 1, 2, root 3. 30 goes by the root 3, 60 is my other angle. So for 30 degrees, I'm going to be looking at this triangle right here. My x-coordinate, I'm going to be using cos of that. So cos of 30 is my adjacent, so root 3 over hypotenuse, so 2. So this is root 3 over 2, and this is going to look really tight on my page, and I'm really sorry for that. And that doesn't even look right. Root 3 over 2. And then the y-coordinate is going to be sine of theta. So sine of 30. So here's my 30. My opposite is 1, and my hypotenuse is 2. Now, in this quadrant, I'm going to have to think back to CAST. C-A-S-T. In this quadrant, everything is positive, so I don't have to worry about putting any positives or negatives in here, okay? You're going to be able to finish off all of these knowing that they're all positive. I'm going to give you a little bit of help, and I'm going to go ahead and I'm going to calculate, I don't know, maybe this one for you. So when I look at this one, this is the angle 150. But really, I'm still going to be using the 30-60 triangle, or the 1, 2, root 3 triangle. That's because I need to use my related acute angle. So even though this is 150 degrees, I know that the angle that I'm using is the 30, the 180 minus the 150. So when I do that, I'm going to use cos of 30. And so when I get cos of 30, I know that it's root 3 over 2, except in this quadrant, cos is negative. Sine is the only thing positive in here. So I need to make sure that I put a negative in front of that root 3 over 2. Now, sine of 30, we already figured out is 1/2. And since we're in the S quadrant, I know that I'm going to leave it as a positive number. This is going to take practice. It's probably going to take you a little bit of time. You're probably going to get some of them wrong, and that's okay. So what I'm really going to recommend is you draw this special triangle out on your page, you start to work through, and you check every single angle that you're doing. So draw it out, pause the video, start working, and on the next screen, I'm going to be showing you your filled in or your completed unit circle for you to double check as you go. Here's the completed unit circle. Like I said, please try and finish this in your notes. Ask me if you have any questions, but you should just be using those 2 special triangles and you should be able to figure out all of these answers.